Everyone, CK this side. I'm a senior software developer in one of the UK-based consultancies. The topic which I want to discuss today is how you can migrate your existing microservice architecture to follow contract testing. Suppose you are in an e-commerce domain and you have multiple services. You can have a cart service, product listing page, reporting service, search listing page, PDP, and all. And the service can communicate to each other in in both of the directions. In microservices architecture, this is a typical way services communicate. There could be some other microservices event-driven communication, which can also happen. So, what I've seen in multiple scenarios, when we start the architecture, we tend to follow integration testing approach. Maybe not now, but maybe a few years back, we used to do that. And now those services are live in production. And because integration testing can lead to many challenges, they give you confidence, but they led to many of the issues also. Because when you start it initially, they are fast. In start, they are going to be fast because you have less interaction, you have less number of services, and you have less number of integration tests. So they are going to be fast. But as soon as you grow, you add one service, two services, and multiple services. Microservice one, microservice two, and every time you add a new integration test, you're adding load to that integration test. And if you know how integration tests runs, they actually interact with the actual running services. So they are meant to be slow, gradually. So with each of the added interaction, your integration test is going to be slow. And then you follow something called CI/CD pattern. CI/CD is when you have each of the commits going to production. And in the CI/CD process, you want to test your flow every time it goes to production. And how do you test the integration is the challenge. So the current flow in the current scenario, what we are following is integration testing. And in integration testing, because all of the services are interacting through APIs, directly calling the services, they are becoming slow day by day. So what happens to your pipeline? Let's say you have a card service. You what you do is make a new commit to this, and now your pipeline gets triggered. You run your unit test, you run your unit test, you run your build, and maybe some of the basic integration tests that you have, like feature tests, or say whatever you have, you ran it, and then this goes to a phase which is a nightmare, which is called integration test. Now this goes to this phase integration test, and now this has to work with some specific versions of each of the other services. Now they are waiting in queue to run one after the other because they can't run in parallel. Why they can't run in parallel? Because when you send them into production, they had to work well together, and they when they had to work well together, you want to test them together. Now let's say one of the services is having a version 1, other is 2, 3, 4, 5. So there is a combination of service versions which works well in your production. So to handle that scenario, you run the integration test for service one by one. Okay. So now because your integration, let's say, takes 15 minutes today to run. 15 minutes may sound a big number to run test, but believe me, this is a very small number which I'm saying. This could actually take half an hour to an hour or sometimes more than it. And then because there are some other services also waiting in the queue to run, let's say these services. Now, suppose this integration test is running and this takes 15 minutes plus 15 minutes plus 15 minutes. So, if I'm making a commit to this service, which this is going to take 45 minutes to run the integration test, not to run their own test, but to also wait for other services to go run the integration test. I hope you're getting what I'm saying. Now this becomes a very big problem because every time you want to even let's say go to a dev environment, you make a commit let's say in 5 minutes and then you wait for an hour to get it deployed. And because integration tests runs on a integration environment, let's say on a dev environment, they tend to fail after some time. They may be flaky because maintaining those integration tests is hard. Believe it or not, how good of a developer you are, managing integration tests for a big microservice which has let's say 10 to 20 my working microservices is going to be really hard. And to figure out which service has broken the test, is it a just flaky test or something else, it's pain. It's a real pain. And when you have distributed teams, um, sometimes blame game happens to happen. Now, let's say you have some teams of 5 people, and then again 5 people, again 5 people. Who owns the breaking chain? Is again becomes a question. Who has broken the chain? Everyone wants to work with their delivery timelines and all. So now the ownership becomes complicated. Who owns the breaking change? And then eventually, because everyone is blocked, everyone come together and then they fix it. But it takes a hell lot of time, and this is a pain. I hope you are getting it. So we now understand why in a microservices based architecture for a big service, why this is a pain, right? Now we know this is a pain, but how to get rid of it? How to make the pipeline independent? So let currently in integration test scenario, if I have 5 services, I have and 5 are in lane, I'll need to wait for 4 to go on just to test my service, even though if it doesn't have anything to do with any other services, even though I haven't pushed any change which will affect. Let's say I've only changed a type or something. That change also needs to take an hour to go to dev environment. How do I fix that? First thing first, we need to eliminate integration testing completely. We can replace it with something which is more efficient, which will give us the same results of getting confident to go into production. But this is painful. That we agree. There are ways to fix it. One is called contract testing, and I'm going to talk about this only, contract testing. So currently, what we are seeing is this. If this is API-driven contract test. This is API-driven contract. This is also API-driven contract test. And how we are testing is by making actual API calls to those services and getting the response in actual scenario. Now, what if we say instead of actually calling these services, or I have a contract between a API contract between these services. Now I have a contract between those services, and what I verify once let's say I deploy this SLP service, and SLP service has a contract with PLP service. What I verify is the contract between that, the API contract between them, every time I deploy is valid. Validate API contract. So if I can validate if the contract is valid, I can trust that when the actual integration happens, this will work fine because what I'm doing is hitting their APIs. And if the contracts are not broken, this is going to work fine. How this gives me an advantage? Now, this gives me an advantage of not making actual call to PLP service. Rather, I have some tests in my own service. Let's say I have added some sets of contract testing here. Now I have my own set of testing here, which is like contract. And then every time I run this contract and this validate this works. Now, one of the biggest exam advantage that we get over this is now this SLP service pipeline becomes independent. Now this can go alone to the dev environment because I check all this can have multiple contracts by the way. This is not that it's consuming only one service. This can have contract with many services. And what I do is I check the contract with all the services. This may be a producer also. So I again check the services which I'm providing my APIs to also works fine. So this is a two-way communication all the way. But the advantage which we are all together saying is this becomes independent. And we can now replicate this for any other services. We say PDP service. We say reporting service. We will need to replicate this with all the services. Now, once we do that, the magic happens. How this happens is, let's say I push something in the reporting service. I have a commit to this. Now, this commit goes to pipeline. What I do is I run my unit tests. I run my feature tests. Feature tests, I'm talking about Cucumber test. If you have it, you run it. If you don't. I run my build. And then finally, instead of running integration tests, which actually wait for multiple service, what I do is I run the contract test. I verify the contract. And if this goes green, what I do is I deploy my service to environment, deploy. Now, this gives me same confidence to go live because all the contracts are valid. I can independently go and I can replicate this for all the services. And the advantage that we see here, the coupling is now not there. And every time it's the same for all the services. I can do this for all the microservices, and now all the microservices are independent. And now modern services uses this similar pattern. They don't go via integration test path because this is proven and tested that integration test becomes slow when you have a lot of microservices in picture. And contract testing solves the problem. And contract testing are just unit tests. They are basically unit tests, a JSON which has your contract and you just validate them. So it becomes very independent. Now we have seen this that contract testing can solve the issue. But how do I migrate is still a question. On paper it seems like very easy. Now I have migrated all the services, but in reality it's not that easy. Once you have those changes, it becomes really painful to migrate to other services. This really becomes painful. So let's now go to the initial interaction that we had and try to see how we can step by step take baby steps to migrate it. Now, first of all, you need to identify what are your consumers, what are your provider. Same service can be a producer and consumer, but you need to cater a list of consumers and providers. First, you need to identify this. You need, if you have a interaction diagram for your service, well and good. If not, create one. We create all the consumers, all the providers, and then we try to define the interaction slash product or slash um, product slash card or anything. You try to define the interaction. And then you take one API because you can't just do a waterfall model, big bang release. You one day you go, you eliminate all the integration tests and you say, no, I'm context driven from today on. No. This is not a practical scenario, and this can lead to many challenges. Suppose you took just three APIs, and then based on the interaction or integration test, you try to define a contract between those. Okay, and once you define the contract, okay, once you define the contract, you write contract test for them. There are many framework which comes on the way to implement contract testing. But what you do, I'll talk about one of the frameworks at the end. But what you do is you take one portion of your system, you migrate it, and you take that, replicate that to multiple service, and this is the way you can take this forward. Don't go uh, and say I'll change all the APIs and make it work, and I'll stop doing everything else because delivery matters. You're not paying to uh, customer is not paying you to deliver the product via integration test or contract testing. This is more of a developer thing, and the long run, it helps the business to go faster in life, and also the developer journey to be smooth. So the action item which I'm trying to take here is create a diagram of system using which I can define consumers and providers. Take few of the interactions and define contracts for them, or more identify contract for them, not define but identify contracts for them. Once you take them, set up the framework. Once set up the framework, once the framework is ready, you are still on integration test. You are still using both integration tests and contract testing. One thing to notice here is once you start developing on contract tests, one advantage that you get is now your tests are not going to be slower. Let's say it takes 30 minutes to run the contract tomorrow because you're not adding one any more test to integration test, and any new contract that you're adding, you're writing it via contract test. You're not increasing load on the third. This 30 minutes is not going to be 35, 40 an hour because you're not adding any new integration test to that. So make sure once you start it, you don't add any more integration test. Every time you touch an API, you convert that to contract test. Okay, that's the one thing which you can do. Let's say I add one API, new API. I because the framework is set up, I write contract tests for them. I touch an existing API. I convert that to contract testing. Okay, this is the way. Eventually, you will get migrated to contract testing. Eventually, this is not a big bang, but smoothly. You are going to migrate. Let's say it takes 2 months, 3 months, or 4 months, depending on the how big your system is. But this is the smoother way you can go ahead. You will have both the places in the pipeline. You run all the test cases. You go one by one. You need to make sure you go step by step, take baby steps. Okay. So you have a hybrid setup. So how this will behave is you have, let's say, this much of integration testing. This is okay. This is integration test per se. Let's say, okay, this color. You have this integration test, and then you also have a smaller portion of contract test initial. Initially, let's say this much you have is contract. You start with it, okay. And any new things which you are adding is where that you touch one of the portion, you make it contractors. You touch one of the portion, you make it contractors. You touch one of the portion, you make it contractors. And eventually, you will find yourself at a place that there are very few integration tests which are left in the system. And once you reach at that level, that's where you can take a big bang approach, because now you want to eliminate this. Let's say this smaller portion is never being touched. So should that stop you from migrating from integration test to contract testing? No. You take that explicitly because you now know you have a very small portion to replace. Once you replace that, you then will figure out that all the system is green now. Now the integration tests that you are running in the integration test percentage and test, let's say when it comes to 1 or near to 0%, what you do is you take that action. You write, convert all the remaining test cases to contract tests. You go all contract tests, and then you eliminate all the integration test pipeline. Now you find out all the 40 minutes or 30 minutes that you used to take for integration tests are now eliminated, and you are now fully converted to contract testing based approach for all the services. Now, initially, when the pipeline looked more like, so this is now, but initially, what you did had is one, two, three. This was queue. This has to go one by one. Now, the advantage that you get is you are not going one by one. You are going one at a time. When I say one at a time, this has no dependency on other. This can directly go to, let's say, dev environment. And same can go for all the services. Now everything became parallel. Now service one can go independently. Service two can also go independently. And service 3 can also go independently. So the service N can go independently. Now we see this aggregation. Now nothing is independent. Now because you have all the contract testing framework set up, you write tests and you maintain it. And because all the services, so when I write a contract test for this service, I know this is the service I'm working on. So I own this. So ownership is very clear. You own the service, you own the test. These are just unit tests. You own those. So you know where it has broken. The framework which you will be using will give you clear picture where it has broken. So all in all, this gives you hell lot of advantage. Okay. So migrating it will give you a lot of advantage. And also we figured out what could be the steps to take it. So from integration test, the integration flow, we move to contract testing flow. I hope that is clear. If not clear, please let me know. Okay, last question. What are the contract testing framework which can implement? So one which I'm going to talk about is Pact contract testing. This is a very well-known framework. This has many advantages. One is this is a consumer-driven test cases, consumer-driven framework, contract testing. This is language independent. You can implement is pretty much in ignore the typos, please. This is language independent. So you can implement it as Java, Kotlin, Node.js, Python, and many other languages. So this supports most of the famous languages or widely supported languages. You can manage states in it. It's more like a unit test. It provides you a broker where you can see all the interactions and all. So this is basically you can migrate it to cloud very easily. So contract pact contract testing has these advantages. How this is working is how this works is okay. Let's talk about you first. You see, in contract testing, basically pact means contract, a formal agreement between two parties. So let's say you have a service which is consumer, and you have a producer service which produces some API. First, what they need to do is they need to communicate. Okay, they need to communicate to each other and decide on a contract. Once they decide on a contract, once let's say they decide on a contract, then what this is because this is a consumer driven test case. Okay, first consumer will write their consumer test cases, which is nothing but contract using this contract. So this is on paper. Now they will write unit tests using the framework. They'll write contract tests against the fakes of the producer. Now, because you know that the contract has been decided, you can generate a fake and generate a contract. You then publish this to a central place, which is called Pact broker in this framework. You send this contract to this broker. Now, the broker knows this is the contract, and this also has some metadata. Who is the consumer? Who is the provider? When it was published? And what is the result, whether it's been passed or not. So all the information is there with broker. And now what producer does it pulls out the contract. So now it basically downloads the contract. It downloads the contracts and validates against the actual producer APIs. It validates the APIs, does the validation, basically runs the test, and then it publishes the result to broker. It publishes the results to broker, whether it's been passed, failed, what are the keys which didn't match and all. Everything goes to broker. And because broker is a central place and it also has a UI, and because this has a UI, you can go and see whether the test has been passed or failed. And you can integrate that with your pipeline to say your pipeline will fail if the test fails. So now producer pipeline will fail once the contracts are broken, and now they know specifically what failed, for what reason it failed, they fix it and push it, and the pipeline goes as is. So UI looks like, for say, consumer last run, failed or passed. It's really really good. You can search for it and you'll find it has a well defined documentation. And you see, this is very simple. This gives the independence. The only common part is the broker, and rest all is independent. Consumer, they first sit together, decide on contract, they write a contract test against the mock, they publish it, producer downloads the contract, runs it, and publishes the result. That's how things go. This can go for event-driven communication also, but I'm not going to talk about it. This is basically API-driven contract test, which I'm talking about currently. So now this is all clear. You could choose to uh, search for any other frameworks also, but all defined. But I hope you get the entire point. Where is the pain and why we are trying to solve this problem? Let's recap it. So we started from here, where we had integrate a service which was already there. So let's say you are working on a legacy service which is following integration tests. In consultancies or in also in practicality product company, you focus initially on the delivery. You don't care a lot about the framework or the languages that you use, and that's perfectly valid because the aim is to go deliver, to build something useful, not to use some fancy frameworks and all. So initially, we came together, we build a product which is working using integration tests, but now we want to expand it. We want to build something which can scale. And to scale, what we see is initially we didn't thought about it, that the integration test is going to be a bottleneck in the picture, right? So we came with integration tests. Now, initially it was fast, but eventually it became very slow. So the some developer actually raised this issue. How, why don't we fix it? There's interaction, the pipeline is going to very slow. I have to wait for 45 minutes to get my pipeline green. This is very slow. So time to market is very slow. Although we say we are CI/CD continuous integration continuous deployment, but we are waiting for it a lot. So this is painful. This is giving a wrong impression on a developer journey. So what we do? We introduce contract testing. What we do is we don't go big bang. We want to what we want to do is we want to identify the system architecture first. We want to see where the interaction lies. There could be multiple services. There are microservice architecture which has more than 100, more than 1,000 services also. So that could get very complex. And integration tests are painful in that. Now what we do is we identify portion of our system where we can define the contracts. We pick some APIs, we define contract, we identify contracts, and then we start implementing those and putting into the pipelines. Now we do it one by one, maybe service by service, and then eventually we see the services pipelines are going to be independent one by one, and the services tests are also going to be very fast because these are unit tests and they run per service and they are not dependent on any other services. Even if one service is down but the contract is working fine, I can still go ahead and do the changes. Now, what I did is I created the service architecture. I identified my sample APIs, pilot APIs to go with, created contract for it, and then I set up the framework, whichever framework, contract testing framework I want to use. And then I do the changes one at a time. And then eventually I see whole framework or all the system is now green with contract testing. And the framework and the system which used to wait for each of the services, now each of the services are parallelly being deployed, which makes your segregation important and your services are time going to be faster and time to market is becoming low. Now this solves the problem altogether. And this also gives an advantage where your teams could be segregated. And I gave example of Pact contract testing and how this works internally in depth and code wise. You can go read on the documentation, look at for GitHub examples, and you will find a lot. There are a lot of things which uses this, so no problem at all. You can pick them all. Now, this also gives an advantage in your team segregation. Let's say you define your teams domain wise. When you define your team domain wise, the segregation helps us a lot. Now, a team can talk to different team, and that's where defining contracts are very helpful. Now, a team can talk to a different team, and contracts are independent. I can own few services, you can own few services, and things goes fine. So this is actually helpful in management perspective also. So not just technically, but also you get a lot of advantage of managing teams. So BAs, product managers, everyone gets an advantage of it. So yeah, that's about it. If you are listening till here, thanks a lot. I was facing this issue, so just thought of creating this. Just give your feedback and thank you. Bye bye.